Hi student, I am Sumanta Somapatro, your maths teacher. Today we are going to discuss real number. This is your first chapter and most interesting chapter also. Today, before discussing this, the number system, all of you know about natural number, whole number, rational number, etc. etc. In a previous class already you have known about this. Clear? Today we just memorize the previous class number system and also discuss the real number system. Clear? At first we know about natural number. Now what is natural number? Natural number means the counting numbers, the numbers which are used for counting, that is 1, 2, 3, 4, 5, etc. All are natural number. 1, 2, 3, 4 and etc. These are natural number. Clear? Now natural number, and there are some numbers which are not used for counting, but see that in natural number system 1, 2, 3, 4, 5, 6, 7, 8, 9, but after 9 we counted 10. To make 10, that is to count 10, we need a 0, but natural number does not contain 0. So including 0 we form a new number system. These number system are called whole number. So what are whole number? Whole numbers are 0, 1, 2, 3, 4, etc. Clear? All these numbers are whole number. Clear? Now we can say the all natural numbers are whole number, but all whole numbers are not natural number. Clear? Which numbers are is a whole number but not a natural number? 0. 0 is a whole number but not a natural number. So what is the least whole number? 0 is the least whole number. And what is the highest whole number? That is largest whole number. There is no existence of largest whole number because whole number going to infinity. Similarly, in case of natural number, what is the least natural number? Least natural number is 1. Clear? And there is no existence of highest natural number, that is it goes to infinity. Clear? Now properties of whole number. Properties of whole number means sum of whole numbers. Sum of two whole numbers is always whole numbers. Sum of whole number is whole number. Clear? Sum of whole number is whole number, and multiplication of whole number is also a whole number. Clear? Multiplication of whole number is whole number, but difference of whole number is not a whole number. So what is the difference? What is the difference of two whole numbers? A new number system arises then when if we subtract these the two whole numbers. Clear? If we subtract 3 and 5, so 3 minus 5, value of this is minus 2. This minus 2 is not a whole number, so we need to express minus 2 a new number system. This number system is called integer. Clear? Integer. So what is integer? Integer means integer contains all whole number and natural number. If whole number contains in integer, then obviously natural number is also contains in integer. Clear? Now integer means some whole number and there are some number which is not a whole number. Clear? So if we divide integer, what is the type of integer? What are the type of integers? Type of integers are some integers are positive, that is some integers are greater than 0, and some integers are negative, that is some integers less than 0 and the integers 0. So interesting fact is that 0 is neither a positive integer not a negative integer. Clear? 0 cannot be positive and as well as negative. Clear? If we say non-negative integer, then 0 is included in this, and if we say non-positive integers, and 0 is also included in the set, but 0 is neither positive nor negative. So there are difference between positive integer and non-negative integers. Some students think that positive means non-negative and non-negative means positive. These are not right. Clear? So positive integers, positive and non-negative, there are difference between positive integers and non-negative integers. What is the difference? In positive integers 0 is not included, but in non-negative integers 0 is included. Clear? So integers are three types. One is positive integers which are greater than 0, and one is negative integers which are less than 0, and 0 individual a type of integer. Clear? Now properties of integer. Sum, subtract, product of integers are integers. That is, sum of integers, difference of integers, difference, and product of integers are integers. Clear? But division of integers are not integers. So what is the division of integers? If we consider two integers, 5 and 3, if we consider two integers 5 and 3, and if we want to divide 5 by 3 or 3 by 5, this can be written as 5 by 3. This is not an integer. So here a new number system occurs. This number system is called rational number. Clear? This number system is called rational number. So now we know about rational number. Oh, what is rational number? What is rational number? Rational number means the numbers which are in the form p by q, where the condition is must that q not equal to 0 and p and q are integers. The rational number is p by q form, that is 5 by 3 is a rational number. Division of two integers form a rational number. So p by q, where q not equal to 0 and p or q are integers. These number system are called rational number. Clear? Rational number, there are so many types of rational number, that is all integers is also a rational number. Clear? All integers are rational, but all rational numbers are not integers. There are a connection between natural number and whole number and integer and rational number. Clear? Now when we discuss rational number, whole number and integer, natural number, there are some connection between natural number and whole number. That is, whole number is natural number, but all natural numbers are not whole number. And when we compare between whole number and integers, we see that all integers are not whole number, but all whole numbers are integers. Now we compare between rational number and integers. That is, rational number in all integers are rational number, but all rational numbers are not integers. So how many types of rational number are there? There are some types of rational number. One is integers and other is fraction. Other is fraction. So integers means minus 1, minus 2, minus 3, 0, 1, 2, 3, etc. All these are integers, and integers are also a rational number. And fraction number means those numbers which are in the form p by q, where q not equal to 0 and p and q are integers. So 2 by 3, minus 5 by 7, 7 by 2, 1 by 3, etc. All are fraction. This fraction is also a rational number. Fraction are of some types. There are proper fraction and improper fraction. Proper, all of you know about proper fraction, and improper fraction. And type 3 is mixed fraction. Proper fraction, improper fraction, mixed fraction. All of you know about proper fraction. Proper fraction is a fraction whose denominator is greater than numerator. That is the fraction whose value is less than 1. It's called proper fraction. And improper fraction, what is improper fraction? In improper fraction, if numerator is greater than denominator, then the fraction is called improper fraction, and value of this fraction is greater than 1. And mixed fraction, what is mixed fraction? Mixed fraction is there are some whole part and some fraction part. Suppose we consider improper fraction 5 by 3. 5 by 3 is improper fraction. If we transfer 5 by 3 to mixed fraction, this can be written as 1 whole 2 by 3. This fraction is called mixed fraction. Why it is called mixed? In this fraction, one part is whole number, that is integer number, and other part is fraction number, that is whole number plus fraction number, that is integer number plus fraction number is at a time called mixed fraction. Clear? So there are another type of fraction. Another type of fraction means there are some type of fraction, common fraction and decimal fraction. Fraction is also some types. One is common fraction, another is decimal fraction. Decimal fraction. What is common fraction? Common fraction means 2 by 3. This is a common fraction. So in a fraction, if there is some numerator and there is some denominator, then we can say this is a common fraction. And if we consider minus 1 by 5, this is a common fraction, negative common fraction, and 5 by 2, this is also a common fraction. Clear? All proper fraction and improper fraction all are common fraction. And what is decimal fraction? Decimal fraction means we use to express a fraction with a decimal number. Clear? That is 2.3 is a decimal fraction, 3.5 decimal fraction, 1.7 all are decimal fraction. Clear? Now these also a type of fraction and these also type of fraction. Clear? Now decimal fraction or some decimal fraction are of terminating decimal and some are non-terminating decimal. What are terminating decimal and what are non-terminating decimal? So in these two types we transfer one type to another by some method. Common fraction to decimal fraction and decimal fraction to common fraction. At first we transfer common fraction to decimal fraction. Suppose we consider a common fraction, that is 5 by 2. 5 by 2 is a common fraction because there is some numerator and denominator also. So 5 by 2, if we want to 5 by 2 to transfer decimal fraction, then we divide 5 by 2, 2 2 is 4, 1, 0, 2 5 is 10. Clear? That is 5 by 2 equal to 2.5. So 2.5 is the decimal expansion of 5 by 2, which is improper fraction. Clear? Suppose we consider a proper fraction 2 by 3. 2 by 3, no? Suppose consider 1 by 5. 1 by 5 is a proper fraction because numerator less than denominator. If we transfer it to decimal fraction, then we divide 1 5.052 10, that is 0.5 equal to 0.2. So 0.2 is the decimal expression of 1 by 5. Clear? Similarly, some decimal fraction is also transferred to common fraction. Suppose we consider a decimal fraction 3.5. So what is the value of these numbers? These numbers equal to written as 35 by 10. This equal to 7 by 2. So 7 by 2 is the common fraction whose decimal expression is 3.5. Clear? Now decimal fraction and common fraction transfer to each other by some method. All of you know about this. Now there are some fraction which decimal expansion is non-terminating. Non-terminating means, suppose see that 2 by 5. If we express 2 by 5 in decimal fraction, then what is the decimal expansion? 2 5 5.0 5 20. This is the decimal expansion of 2 by 5, that is 0.4. 0.4. This is the terminating decimal. Terminating decimal means decimal expansion end at some times. Okay? After some digits, decimal expansion ends. Clear? Now, if we want to express 2 by 3 in decimal form, then what is the value of this? This value is 3.036 18 2 and again 0 6 18 2 again we get 0 6 18 2 again 0 6 18 2 and so on. 0.66666. Clear? This is non-terminating decimal. Non-terminating decimal means this decimal expansion does not ends. Clear? This decimal expansion, that is 2 by 3 equal to 0.6666 dot dot dot. This is non-terminating decimal. For expressing non-terminating decimal numbers, we use recurring numbers, recurring digit. Okay? So this equal to 0.6 recurring. Clear? So the number we substitute the recurring digit on these numbers which is repeating again and again. Clear? So 0.6666, therefore 6 is repeating again and again. So use recurring digit on 6. That is, this is the decimal expansion of 2.3. Clear? So all these numbers, all these recurring number, decimal, terminating decimal number, fraction number, integer number, all these numbers are rational number. Now we know the properties of rational number. What are the properties of rational number? That is, number one, sum of two rational is rational. Clear? Sum of two rational is rational number. Number two, product is also a rational number. Product of two rational number is also a rational number. Number three, difference of two rational is rational. Number 4, division of rational is also a rational number. Clear? So we know about rational number and their property. Now we represent rational number on a number line. Clear? Suppose we represent 2.5, a decimal rational number on a number line. 2.5. Obviously we know that this number lies between 2 and 3. Clear? Now we consider a number line. This is 0, 1, 2, 3, 4, 5, 6, etc. and this is minus. Clear? So 2.5 lies between 2 and 3, and this is the middle point, 0.5. This is the middle point of 2 and 3. This point is 2.5. Clear? Now if we want to represent 4.3, so this is greater than 4 but less than 5, so obviously it lies between between 4 and 5. Clear? So we divide the line between 4 and 5 in 10 equal parts. Clear? Now this part are 4.1. Now we express another rational number, suppose 4.3 on number line. So obviously it is known that the 4.3 is greater than 4 but less than 5. So this point lies between 4 and 5. Clear? Now we divide the line between 4.5 in 10 equal parts, that is 4.1, 4.2, 4.3, 4.4, etc. 4.3, 4.4, 4.5, and this, and before 5 this is 4.9 and this 5. Clear? Now 4.3 is this point on number line. Similarly, we express we plot any number up to 1 decimal place in number line. Suppose we consider a 2 decimal place number. 2 decimal place number means, suppose we take a number 3.56. How can I represent 3.56 on number line? Clear? Now this 3.56 lies between 3 and 4. Obviously it is known that this 3.56 lies between 3 and 4. Clear? Now we divide 10 equal part between 3 and 4. So what is the point? That is 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9 and then 4. Clear? Now this number is 3.56. So all of we know this 3.56 is greater than 3.5 but less than 3.6. So we expand this part, that is 3.5 and 3.6 in expansion form. That is, we take this point is 3.5 and this point is 3.6. Now we divide this line in 10 equal parts, that is 3.51, 3.52, 3.53, 3.54, 3.55, 3.56, 3.57, 3.58, 3.59 and 3.6. Clear? Now 3.56. What is the point? This point. This point is 3.56. This is the required point we want to plot on number line. Clear? Now we discuss about non-terminating number. We know that 1 by 3, if we expand this number in decimal form, then the number becomes 3.339 1 0 339 1 0 and dot dot dot. That is 1.3 in decimal expansion is 0.333 and dot dot. This is equal to 0.3 recurring. So common fraction transfer to recurring decimal. So how can I transfer recurring decimal to common fraction? Suppose we consider 0.3 recurring. So this can be written as 0.3333 and so on. That is, we consider this equal to x. Now if we multiply 10 both sides, then this number transfer to 10x, this equal to 0.333 and so on, this into 10, then this implies 10x equal to 3.33 and so on. Clear? Now x equal to this, we consider this is equation number 1 and we consider this is equation number 2. Now if we subtract 2 minus 1 we get 10x minus x equal to 3.3333 and so on minus 0.3333 and so on. Clear? Now 10x minus x, this equal to 9x and 3.3333 minus 0.333, that is 3. Clear? Now x equal to 3 by 9, this equal to 1 by 3. Okay. So the non-terminating number by this way we transfer to fraction number, common fraction. Clear? Now if we transfer another terminating, we consider another terminating number 2.31. Clear? There are 2 decimal place, 2.31. Now we consider this equal to x. 2.31 means this can be written as 2.31, 31 and so on. Suppose we consider this equal to x. So see that there are 2 digit recurring digit, 2 number with recurring digit. Clear? So we multiplied this number by 100. So 100x equal to 231.313131 and so on. Clear? Now if we subtract this to this, 100x minus x, that is 99x, this equal to 231.313131 and minus 2.3131. See that 231.313131 and so on and 2.313131 and so on. If we subtract from this to this, then we get 9. After decimal all numbers are 0 and this is 9, 2 and this is 2, 229, 99 equal to 229. Clear? Now x equal to 229 divided by 99. Okay, this is the common fraction whose decimal expansion is 2.31 recurring digit and the transformation of recurring digit to common fraction, that is 2.31 recurring can be written as 229 and by 99. Clear? Now we take a shortcut method to express any decimal digit, any non-terminating recurring digit to common fraction. How can I transfer a non-terminating recurring digit to common fraction? So if we consider a recurring digit 0.563 and this is 2 decimal. So what are the steps? Step 1, first step is we hold the number without recurring and without decimal. This equal to 563, and then subtract from this. Second step is subtract from numbers which have no recurring, that is no recurring part is only 5, we subtract 5, divided by, we write the number of recurring digits is same number of 9. Here number of recurring digit is 2, so we write 99. Clear? And after decimal, number of non-recurring digits equal to number of 0. So after decimal, number of recurring digits क्या है? 1. Only one number is there after decimal which have no recurring, 5. So we place here 10. Clear? So this equal to 563 minus 5. 563 minus 5 means 5, 8 by 990, and we transfer it to list form. Clear? Similarly, suppose we consider 2.317 and 17 is with recurring. Clear? We transfer this recurring number to common fraction. So first step is without recurring, without decimal, we write total number. Total number means 2317. Now subtract the number which have no recurring, that is 2 and 3, divided by number of 9 which have recurring digit. There are 2 digit recurring, that is number of 9 is 2, and after decimal number of non-recurring digit is 1, so we replace 10. This equal to 317 minus 3, that is 4, and 9 990. This is the common fraction whose decimal expansion is this. All these are rational number, and the rational number expressed in the form of decimal digit. Then this decimal digits may be recurring or non-recurring, that is terminating decimal and non-terminating decimal. Now we know about those numbers which have non-terminating but non-recurring, that is there is no repeating and there is no terminating and non-recurring also. So what are the numbers which have non-terminating and non-recurring? Suppose we consider a number 0.01, 001, 0001, 000001, 0000001, and so on. So see that in this number we cannot replace recurring on any digit. Clear? And this also a non-terminating number, non-terminating decimal. This type of number is called irrational number. Clear? This type of number is called irrational number. So irrational number is those number whose decimal expansion is non-terminating and non-recurring. Clear? There are two type of irrational number. One is algebraic irrational number and other is non-algebraic irrational number. What is algebraic irrational number? Suppose we consider an equation x square equal to root 2. X square equal to root 2 so x square equal to 2. Then x equal to plus minus under root 2. This under root 2 is an irrational number because decimal expansion of root 2 is not terminating and non-recurring. Clear? Similarly, root 3, root 5, root 7, all these are irrational number. Clear? But root 9 is not an irrational number because root 9 equal to 3. Root 4, this also not an irrational number because root 4 equal to 2. Clear? Now we consider another type of, this is one type of rational number. This rational number is called algebraic rational number because this is a root of an algebraic equation, x square equal to 2, then x equal to root 2. But there are some irrational number pi, exponential, e. These numbers are non-algebraic irrational because these are not a root of polynomial equation. Clear? Now root 2, root 3, root 4, root 7, all these are irrational number. So what is the properties of irrational number? Irrational means non-terminating and non-recurring, that is those real numbers which are not rational are called irrational number. Clear? So therefore there are two type of real number, one is rational and other is irrational. Now properties of irrational, properties means sum, difference, product and division of two irrational number may or may not be an irrational number. Clear? All these, sum of two irrational number may or may not be irrational. That is, if we take an example, root 3 plus root 2. Root 3 is an irrational, root 2 is an irrational, root 3 plus root 2 is irrational. But root 2 and minus root 2, sum of these two irrational number is equal to 0, which is rational number. So sum is not necessarily a irrational number. Clear? Similarly, we prove difference, product and division of two irrational number may not be a irrational number. Clear? Now we express an irrational number on number line. Clear? Suppose we express root 2. We express root 2 on number line. Suppose we consider a number line 0, 1, 2, 3, 4, 5, 6, 7, 8 and so on, and minus 1, minus 2, minus 3 and so on. At first our target is express 2 in sum of two numbers. It is 1 plus 1, which are two perfect square number. In a right angle triangle there are a theorem, the relation between hypotenuse, perpendicular and base. Hypotenuse, perpendicular and base is hypotenuse square equal to perpendicular square plus base square. This is Pythagoras theorem. Clear? We apply this theorem on only right angle triangle only. Clear? Now root 2 can be expressed in sum of two numbers 1 and 1. One is a perfect square number and second one is also a perfect square number. Now we consider a right angle triangle whose base is 1 and perpendicular is 1. Suppose we consider right angle triangle, this base is 1 and we draw a perpendicular on this line and perpendicular is 1 and join O and P. Suppose we consider this point is P. So this is the hypotenuse of this triangle, and hypotenuse square equal to 1 square plus 1 square, that is 1 square plus 1 square, it is 2, that is hypotenuse equal to root 2. So length of this line OP is root 2. Now we measure this line by a compass and plot this point, and this point is root 2. Clear? This is the point on number line which represents root 2. So root 2 lies between 1 and 2. Clear? Now if we want to represent root 3 on number line, then how can I represent root 3? By similar way, 0, 1, 2, root 3. Root 3, the 3 can be expressed in the form 2 plus 1 or 1 plus 2, clear? Now, this equal to 2 can be expressed root 2 square plus 1 square. So, we consider a right angle triangle whose base is root 2 and perpendicular is 1. So, what is the right angle triangle whose base is root 2 and perpendicular is 1? So, before drawing root 3, we must draw root 2. How can I draw root 2? 1, 1, this is 1, this is 1 and this was root 2, clear? Now, we draw a perpendicular on this line, that is OP. We draw a perpendicular on OP with, this is base, this is root 2, and draw a perpendicular, length of perpendicular line is 1, with this line is 1, and if we join this and this is OQ, then this line is root 2, root 3. Now, we take the measurement of this line and plot this line, number line. This point is root 3, clear? Similarly, we plot any irrational number on number line by similar way. Okay. This is the total number line, total real number system, irrational number and rational number. At a glance, if we see that total number system, see this chart, real number is divided into two parts, rational number and irrational number. See that, and irrational number there is no division, and rational numbers are of two types, integers and fraction. Integers are of types natural number 0 and negative integers, and fraction are of types, see that, proper fraction, improper fraction. The fraction which is greater than 0 is called improper fraction, and the fraction which is less than 0 is called proper fraction. Clear? Less than 1 is called proper fraction. Again, fraction can be divided in two parts, common fraction and decimal fraction, and decimal fraction are of two types, terminating decimal and recurring decimal. Terminating decimal are two types, pure terminating, that is 0.5, 0.75, and mixed terminating. Mixed terminating means 2.5, 3.75, all these. Mixed terminating means one part is whole number and another part is decimal fraction. And recurring decimal also are of two types, pure recurring, mixed recurring. Pure recurring means there are no numbers, that is no digits without recurring, and pure recurring means all the numbers, that is all the digits have recurring numbers. Clear? This is total number system. Have a nice day. Thank you.